Okay, this video will address how to use the law of sines. It's not going to address the trouble with the law of sines. In order to talk about that, feel free to watch the other video, Trouble with the Law of Sines. But for this, basically the idea is all the trig that we've been doing up to this point has been right triangle trigonometry. Or some basic trig can be done using SOHCAHTOA on triangles such as the one on the left. You've got a 60-degree angle. We're working with the opposite and the hypotenuse, so very quickly and easily we can define that as the sine of 60 degrees equals x over 15. A little bit of multiplying to move that 15 over to the left side, and typing that in the calculator carefully, you'll find out that that side length, that height, right now is 12.9904. Now realize it's not drawn very accurately on the picture, as the 60-degree angle kind of looks like the smaller angle, but according to the numbers, that's what x is going to come out to. We can also use some basic trig, again, using that right angle to find angles. We know the adjacent and the hypotenuse, so very quickly we can say that the cosine of x in degrees will be equal to 12 over 20, and we can use an inverse cosine to find the angle. And when you type that in the calculator, again, you'll get radians first more than likely, but if you convert that, you can quickly find out that that's 53.1301 degrees. Now the problem comes in when we have a triangle that doesn't have a 90-degree angle. And it's not even a possibility considering that angle B is 103 degrees. And remember that all three angles on a triangle have to add up to 180 degrees. So the first thing that we want to figure out if we want to solve the given triangle, and we don't need a lot of new information for, is what is the measure of angle A. And remember that the measure of angle A will be equal to 180 minus the sum of the other two angle measures. So the measure of angle A equals, well, 103 plus 28 is 131, and 180 minus 131 would be a 49-degree angle. So we can place that inside our triangle. Now the problem we run into is we don't have a right angle. But the nice part is we do have a law called the law of sines. And it's basically a proportion problem. It's using the idea that the sine of A is a proportion to begin with, and the sine of any angle in proportion to its opposite side will be equivalent to the sine of any other angle in proportion to its opposite side, or in ratio with its opposite side. And you can use that for any one of the three angles and sides. So the next step for us is going to be, well, 49 degrees is opposite 26. So I can take advantage of the fact that the sine of 49 degrees is to 26 as the sine of any of my other angles. So if I want to find, for say, side C, well, the sine of 28 degrees will be in ratio to side C. Now you can quickly cross multiply and divide. Remember, you've got your proportion here, so a fraction equal to a fraction. So 26 sine of 28 will be equal to C sine of 49. And if we divide by our sine 49, C will be equal to 26 the sine of 28 over the sine of 49 degrees. And if you make sure you're in degree mode or you're using your degree symbols, and you type that in very carefully, you'll end up with 16.173 for a side length on there. Now realize it's not a right triangle, so you are not going to be allowed then to use the Pythagorean theorem. But the beauty is, if we just set up another law of sines, we can say again that the sine of 49 degrees is to 26, a nice proportion there, as the sine of 103 degrees would be to side B. So this other side here, again, opposite capital B, is side B. So we can find that other side. Go ahead again and cross multiply and divide. 26, the sine of 103 degrees. Sorry, getting kind of cramped in there. Let me rewrite that for you. The sine of 103 degrees equal to B sine of 49 degrees. And divide that over. B will be equal to, again, 26 sine 103 over sine 49 degrees. Type carefully and you'll find out that the third side is 33.567 units. And again, a great idea is to double check that that obviously is our largest side. It's opposite our largest angle. While 16 plus 26 is about 42, which is definitely greater than 33. But neither side individually is greater than 33. So it's a great thing to double check. Go ahead. Here's a couple more examples for you. Think about how you could use the law of sines to find x. You may not have the information directly, but remember the biggest key to the law of sines is, do you have an angle and its opposite side so that you can set up that proportion? Take a second now and see if you can set up those proportions. Okay, so the sine of 34 is going to be to the side 14 as, now the tricky part is we don't have, again, this third angle in order to set it up opposite x in order to solve sine of that unknown angle. So again, 180 minus 110 would be 70, and 70 and then subtract another 34. Basically, 70 minus another 34 would be 36. So that's going to be a 36-degree angle. So sine of 36 is to x down here. Again, cross multiply. 14, the sine of 36, equals x, the sine of 34. Divide, x will be equal to 14 sine 36 over sine 34. And if we type that carefully into the calculator, you'll find out that that's 14.716 units. There you go. Go ahead and think about that second blue triangle if you haven't already. But if you have, we'll get that going in just a second. All right, and here's the answer for you worked out over here at the right. The sine of 95 degrees is to 25 is definitely helpful. We've got an angle on its opposite side. The downside is that we don't have the other angles to work with yet. But remember, we can use that side of 19 to find theta over here. The sine of theta would be in proportion or ratio to that 19, just as sine of 95 was to 25. A little bit of cross multiply, or just multiply that 19 over to the left side. And then notice, to find the angle, again, we need to take that inverse sine. We're going to take the sine to the -1 of our proportion there, which gives us 49.210 degrees. Thinking about that 95 and the 49 degrees, if we add those two up to subtract from 180, we'll find angle alpha over here in purple. And once we've got angle alpha, we can say that the sine of 35.790 degrees is in ratio to x as the sine of 95. Again, our good angle and our good side is to 25 down here. Again, go back and reuse your good sides if you can. Don't try to use those rounded numbers. The more you reuse the rounded, although we're basing a few things on them, we don't have any other choice, the more we reuse them, the worse our numbers are going to get. So try to not reuse those too many times. But we've got our answer down here of 14.7 or 676. There you go. Well, I hope that helps you with the law of sines. Again, that's just the basics of how to use it. The key is, again, having an angle and its opposite side so that you've got at least one of those two ratios worked out. Good luck and have fun.